All right. Hello and welcome to the answers to last night's daily quiz questions. Number one, f of x equals the integral from 4 to 3 or 4 to x of cosine 3t squared dt. So first off, we need to find the derivative of this, and we're looking for the derivative of an antiderivative. Well, you should know by now those are opposites, so they cancel off. So when we do our f prime, cosine, the derivative will cancel off. We'll have cosine, and then it won't be 3t squared because of this x there. It needs to be substituted in. It'll be 3x squared. And then you multiply by the derivative of that, which is 1. I'm not going to show multiplying by 1. And then you subtract when you plug in a lower limit and multiply by the derivative of that. Well, the derivative of a constant, 4, is 0. So that's going to cancel that off. So we're just left with f prime of x equals cosine of 3x squared. Now comes the fun one. Excuse me. First off, a lot of you on this question, it says find the extremas. You just looked at the graph and said, okay, here's a max, here's a min, here's a max, here's a min. All right? The problem with that is this is a graph of f. And the question says extreme values for g. So that doesn't work. We need to find extreme values for g, not for f. If the question says f, these are the answers, and you would give me those ordered pairs. But that's not what the question says. So that's all wrong. So what we need to do is we need to go in and say, okay, to find the extreme values for g, we need to first find the derivative of g. G prime of x equals, well, the derivative of 3 is 0, plus, and then this is an antiderivative. Derivative of the antiderivative cancels off. We get f of x. G prime of x equals f of x. So we have extrema anywhere g prime of x equals 0 and there's a change of sign. Well, that's wherever f of x equals 0 and there's a change of sign. Meaning it goes from positive, the f of x goes from positive to negative or vice versa. Well, here, f of x is positive because it's above 0. Here it's negative. Here, f of x is positive, and here f of x is negative. So, the extreme values are here. That is a maximum because g prime switches from positive to negative. Here's a minimum because g prime switches from negative to positive. Here's another maximum. And don't forget the endpoints. Here is a minimum because the function increases afterwards. And this is a minimum as well because the function is decreasing into it. All right, so the locations of the extrema are what we just said. X equals, all right, x equals 2, negative 2, and 2 are where we have maxes. Then x equals negative 4, 0, and 3 are where we have mins. Does it ask where? No, it wants the actual values. So now we got to go and take these and put them into this function. And when you do that, use the areas. This is a triangle. This triangle has an area of 2. This is a semicircle. It has an area of 1/2 pi times 1 squared, which is pi over 2. This is a triangle, the base of 2, the height of 2. 1/2 base times height is 2. And here we have a triangle. Base of 1, height of 2. This triangle has an area of 1. All right? So when we find the relative maxes, I didn't need to label this properly. These are mins. So when we find the relative maxes, the max at -2, and plug -2 into here. Well, 3 plus, this ends up being 0. So one of the maxes is 2, 3. All right, another max is here. If we throw 2 in here, it'll be 3 minus pi over 2, because this circle's under the axis, plus 2. So 3 plus 2 minus pi over 2 is 5 minus pi over 2. So the other max is 2 and 5 minus pi over 2. And it's okay to have two maxes because the question says relative. So you should name all of them, not just the absolute. Our mins, then, happen at -4. You throw -4 into here. It's 3 plus, start at -2, go backwards. So because we're going backwards, we'll use this as a negative. So 3 plus -2 is 1. So the first min is at -4, 1. The next min will be right here at 0. If I throw 0 in here, it'll be 3 plus this, which is -pi over 2. So the other minimum is at 0, 3 minus pi over 2. And the last min is at the other endpoint. That'll be 3 minus pi over 2 plus 2, which is 5, minus 1, which is 4. So 4 minus pi over 2 is the last relative min. That one was quite involved, but you gotta read carefully. Remember, you're asked about g of x, but the graphs of f. Right? Pay close attention. They love to try and trick you with that. All right. Use the following table to estimate the integral from 4 to 7 of g of x. Use left sums. Left sums means these are the heights. There will be on the left sides of the rectangles. The bases of the rectangles are here. This is 1. This base here is 0.5. This base here is 0.5. And this base is 1. So we'll take all these bases and multiply them by the heights. Notice how I'm drawing and connecting them to the left. When you do all that, then you'll add the result. So 1 times 8 is 8, plus 7 times 0.5 is 3.5, plus 6 times 0.5 is 3, plus 1 times 4. Add those all up, you get 18.5. All right, and the last free response question. A function is strictly decreasing and concave up. Decreasing and concave up looks like that. State whether the following methods will be overestimates or underestimates. All right, so if I do a left Riemann approximation method, I'm going to break this into rectangles. I'm going to find the height from the left side. Well, those rectangles are over the actual function, so this overestimates it. All right. Now we'll do right rectangles. We'll draw the rectangles, and the heights will be from the right side Now we are under the actual area, so it is an underestimate. And then finally, we'll do trapezoids. It's easier to see if we do one trapezoid. Notice how the trapezoid is over top of it. If we do two trapezoids, you'll still see it's over top, just not as obvious. So because it's concave up, a trapezoid is overestimating it, and because the function is decreasing, the left Riemann sum is overestimating, and the right Riemann is underestimating. All right, multiple choice. Let h be the function defined here. Which of the following is an equation of a line tangent? All right, so if we want a tangent line, we need two things. We need a point and a slope. We'll find a point first by doing h of 0. H of 0 equals from pi over 4 to 0. I'm sorry, it doesn't say h of 0, it says h of pi over 4. So it'll be from pi over 4 to pi over 4. Let's rewrite this so it looks proper. H of pi over 4 h of pi over 4 equals the integral from pi over 4 to pi over 4. Right, I'm going to stop right there because anytime this gap is 0, you know it's going to be 0. So h of pi over 4 equals 0. So my point is pi over 4, 0. My derivative, we'll do h prime of x. The derivative cancels the antiderivative. We just got sine squared of x. And if we'll do pi over 4, h prime of pi over 4 equals sine squared of pi over 4. Right? The sine of pi over 4 is square root of 2 over 2. If you square that, you get 2 over 4, which is 1/2. So we have our point. We have our slope. Using point slope form, it's y minus 0 equals 1/2 times x minus pi over 4. And the one that matches that is D. There's our tangent line. And finally, the sixth one. The function is continuous and has values given in the table above. Use subintervals given there. What is the trapezoid approximation? Now, if you look, here the base is 3, here the base is 2, and here the base is 1. Well, that's just letting you know that you have to do your trapezoids separately. You can't do them all at once. So I should see 3 separate calculations for trapezoids. 1/2, the first base is 3, and the sum of the heights, 10 plus 30, is 40. Plus 1/2 the second base, which is 2, and the sum of the heights is 70. Plus 1/2 the third base is 1, and the sum of the heights here is 60. All right, get that all worked out, and it works out to C, which is 160. All right, check those out and get ready for tomorrow's test. Any questions, find me in the morning.